Hi everybody, I'm Roy Barnes, lead developer of VPLanet. In this video, I'm going to describe the examples in the GitHub repository, as well as vplot, which is a separate package that facilitates the efficient production of plots for either a quick analysis of a recent simulation or to generate publication-ready figures. Let's begin with the examples. There are currently several dozen examples in the repository as of September 2023, which can be found at this URL. Each of these examples demonstrates a unique capability of the code. One of the key aspects of these examples is that they provide a starting point for you to build your own simulations for whatever phenomenon you're interested in simulating. In other words, when you begin a new VPLanet project, you should find the example that most closely matches the type of problem you're trying to simulate, and then copy that example directory to a new location and modify the input files to match the system you're interested in. In addition to these input files, there is also a Python script in each of the examples called makeplot.py that generates the figure. In general, the examples reproduce past results and observations. However, in some cases, VPLanet was the first code to simulate a specific type of phenomenon, and so the example shows a representative system. Here is the landing page for our examples, where you can see that we provide a brief description of each example and that we group the examples by phenomenon. I'm not going to show you all of the categories in this video, but you can see the first two in the screenshot. The first category shown is called General, and it demonstrates how to perform a parameter sweep using vspace, multiplanet, and bigplanet, which are separate scripts that facilitate parameter sweeps and manage your big data. Other videos on this channel describe how to use those scripts. The next category is atmospheric escape, which is, of course, examples related to the loss of an atmosphere. You can see the first example in this section is called Abiotic O2, which simulates the production of oxygen due to water photolysis and hydrogen escape. Note that in the brackets are the modules that the example employs, Atmesc and Stellar in this case. There are many more categories, but I'm not going to go through all of them in this video. You can, of course, peruse the web page yourself and explore examples related to orbital dynamics, planetary interiors, stellar evolution, etc. You should be able to reproduce every figure in the repository on your own computer. Let's now look inside one of the examples to see what is included. For this video, we'll examine the binary tides example, which simulates the orbital evolution of a tidally interacting binary star during the pre-main sequence. The example includes some information about what this simulation is demonstrating, who created it, which modules are applied, and about how long the simulation should take on a typical workstation. And then, at the bottom, is the command you need to run to create the figure that is included in the example directory, which we'll get to in the next slide. In all the examples, the command is the same: Python makeplot.py, followed by the format you'd like for the output figure, either PDF or PNG. Each example contains a makeplot.py file, and I'm going to return to them in a few slides. As I mentioned, each example directory also includes one or more figures, which represent the expected output of both the VPLanet simulation and the makeplot.py file. The binary tides example is designed to reproduce a figure from Zahn and Boucher in 1989, who showed that the coupled rolls of tides and stellar revolution during the pre-main sequence circularized binary star orbits out to about an orbital period of 8 days. Next, let's look at the makeplot.py file in more detail. These files perform two tasks. First, they run VPLanet, and second, they create the figures that are in the example directories. Each makeplot.py file imports two custom Python modules. One is called VPLanet and the other vplot. The VPLanet Python module performs VPLanet simulations and can access and organize its output. This Python module should not be confused with VPLanet itself. The Python module VPLanet is just a convenient way to interact with the VPLanet code inside of a Python script. The vplot module enables you to create consistent figures from VPLanet output. Next, I want to show you how to use the VPLanet and vplot Python modules. The VPLanet Python package includes a few different functions for interacting with VPLanet. First up is getOutput, which gathers all of the information from the log and forward files and inserts them into a variable. The other function is called run, which performs the simulation and inserts the results into a variable. In the examples I show here, the variable output contains all the data generated from your VPLanet simulation. Note that if you use the run command and you have already performed the simulation, VPLanet will not rerun the simulation. The output variable organizes VPLanet output into convenient data structures. For example, suppose you performed a simulation of the orbital evolution of the solar system and wanted to access the array of eccentricity values of Earth over time. Those data can be accessed as output.earth.eccentricity. These data are housed inside a NumPy array. You can also access the log file data through the output variable. For example, to obtain the initial value of Earth's eccentricity, it's output.log.initial.earth.eccentricity. And that's a bit of a mouthful, but the structure makes it easy to access any data you want. You can change the components like initial to final, and Earth to another body's name, and eccentricity to another valid parameter, such as, say, inclination or surface water. The vplot package basically overrides the matplotlib package to apply a standard font and some standard colors for your figures. With that introduction, let's peek inside the example makeplot.py file. As you can see, you can add comments like usual, and there are a handful of packages that need to be uploaded. Note that the last two are vplot and VPLanet. After that, we move on to the details of the algorithm. There's a definition of the path where the in files are located, but the important part comes next. Here, the script leverages VPLanet's ability to both run VPLanet as well as place the output into a variable. The final line that is shown just creates a shorter name variable that represents the simulation time. Finally, that ... at the bottom just means that I'm not showing you the entirety of this file. But this part demonstrates how you interact with the VPLanet Python package. What's not shown here is vplot, because there's not much to show. As I mentioned, vplot overrides matplotlib in this script. So just use matplotlib as you normally would, and vplot will modify the figure to include large font sizes, a font that is similar to Palatino linotype, and a figure layout that is optimized for VPLanet. But there are a few things we need to cover about vplot before we wrap up. vplot is a Python package that exists in a separate repository from VPLanet, and it includes its own examples and documentation. There are two ways to use vplot. First is on the command line as an executable. In this mode, vplot generates figures that contain the time series data of a simulation. The use case for this is to quickly examine the results of a simulation to either check for mistakes or gain some immediate insight into the results. The formatting will probably not be ideal. It's just a quick way to see your results. The second mode for vplot is what I just showed you in the makeplot.py file, so I won't go over that again. To use vplot from the command line, just type vplot in the directory that contains a simulation. There are some command line flags you can use. Please check vplot's documentation to see what's available. In this slide, I'm showing you the results from running vplot in the circumbinary orbit example. vplot creates figures that contain the evolution of an output parameter over time. So each of these figures will be its own window on your screen. Here I've just collected them all together to make it a little easier to see. These different panels represent different orbital elements over time. The circumbinary planet is in blue, and then the stellar binaries orbit is in orange. Note that vplot groups the outputs by their type, and each body will of course be printed with a unique color. Essentially, all vplot does when you run vplot from the command line is gather all the parameters listed after the SA output order option, group them by output parameter, and then create the figures. Finally, I want to note that we have selected a handful of colors that are chosen for accessibility. When plotting a curve, simply include one of these 5 variable names after your color keyword in the plotting command, and Python will use that color. These 5 colors plus black represent 6 different colors you can use in a figure and should cover most use cases. We found that if you want to include more than 6 curves in a figure, you should probably change the line style to dots or dashes to distinguish those parameters from others. This concludes this introduction to VPLanet examples and vplot. I hope you found it helpful, and good luck with your research on habitable